In this video, we are going to be working on absolute value equations. The objectives are to solve, to state why some of these equations have no solution, and then to state why there might be two solutions to absolute value equations. Just a reminder, absolute value is the distance a value is from zero on the number line. So when we're talking about distance, we're talking about how far it is away from zero. For example, the absolute value would maybe be talking about that we could be 3 units from zero to the right, or we could be 3 units from zero to the left. Both of these are 3 units. So when we're talking about that, please remember the symbol for absolute value are 2 vertical lines. And then if we're using this example, the absolute value of -3 would be 3 because it's 3 units away from zero. And the absolute value of +3 is also 3 because it is 3 units away from zero on the number line. So remembering that absolute value is talking about distance. Therefore, we should be able to do some evaluations. The absolute value of 5 is 5 units from zero on the number line, so is 5. Absolute value of -9 would be 9. In this situation, where we're getting into a little bit more of a complex problem, remember that we're going to do the absolute value first. So the absolute value of -3 is 3, and then we take care of anything that's on the outside of the absolute value. So that would then become a -3. In the next example, we have a problem. So we have 7 minus 13, and we're going to do that inside the absolute value first. 7 minus 13 is -6. And then we will take our -6 and we're going to divide that by 3, which is -2. We'll finish up by saying that the absolute value of -2 is 2, and 12 minus 2 would be 10. When we're solving an absolute value equation, what we're going to find is that inside the absolute value symbols, there's going to be some sort of variable expression. For instance, we might have something like x minus 6. So inside is some sort of variable expression. And then it's going to be equal to some value. And that value is going to describe the distance. For example, we might put 11. This is a value, and it represents the distance. What we talked about before is that the distance from zero on the number line could be to the right or to the left. We're not sure which one we're going to be talking about. So in that situation then, we are going to find out that there are going to be 2 different solutions. We could be at 11 or -11. So when we're solving in absolute value equations, we need to set up 2 different situations or cases, one of which was at 11 and one of which would be at -11. And therefore, we also will get 2 solutions when we finish solving. If we finish solving and we added 6, we would get an answer of 17. Does that work? So we put 17 in here. 17 minus 6 is 11, and the absolute value is 11. If we add 6, we're going to get a -5, and if we replace that into our absolute value, -5 minus 6 is -11, and the absolute value of negative 11 is positive 11. So there will be two solutions when we are solving our absolute value equations. One of the biggest things to remember when we are solving an absolute value equation is to make sure to isolate the absolute value sign. That means that we need to make sure that the absolute value expression is by itself. So my first step would be to subtract 6 from both sides, and that's going to leave me the absolute value of x minus 7 is equal to 3. And then at that point, that is where I set up my two special cases, one of which would be at 3 and one of which would be at negative 3. And then you can finish solving from there by adding 7 to both sides. So x will either equal 10, or when I add 7 to both sides, x would be equal to 4. Again, we can do our check. We can substitute 10 into our absolute value. 10 minus 7 would be 3. The absolute value of 3 is 3 plus 6 would be 9. Or if I put 4 in, 4 minus 7 is negative 3. The absolute value being 3, and 3 plus 6 would equal 9. So let's practice solving some absolute value. We'll start with a simple example and we'll work our way to some more difficult ones. So the absolute value of what number is 4? In other words, what could this have been to begin with? Well, it could have been 4, or it could have been a negative 4 because it's the distance from 0. If there is an expression inside the absolute value and it is isolated, meaning there's nothing outside of the absolute value symbols, we can set up our two situations to solve, our two equations to solve right away. So we have k plus 3 is equal to 2, or k plus 3 is equal to negative 2. And then we can go ahead and solve and come up with our two answers. So we'll do the opposite operation and we'll subtract 3 from both sides. K then is equal to negative 1, or when we subtract 3 from both sides of this equation, we can see that k is equal to negative 5. Again, if you'd like to make sure that your work is correct, you can substitute those values back into the absolute value original equation and check your work. If we have 2m, the absolute value is equal to 4, we simply need to set up our two situations right away because we don't have anything outside of the absolute value symbols. So we'll say that 2m is equal to 4, and then we will say that our 2m is equal to negative 4. Alright, so we'll divide both sides by 2. So m is equal to 2, and when we divide both sides by 2, m is equal to negative 2. And again, go ahead and check your work. In example D, there is nothing outside of the absolute value, so we can go ahead and set up our two problems right away, our two equations. We have 2m plus 1 equals 5, and then we have 2m plus 1 is equal to negative 5. So let's do the opposite operation. We're going to subtract 1. So we have 2m is equal to 4, and then we're going to divide both sides by 2. So m is equal to 2. Subtract 1 from both sides. So we have 2m is equal to negative 6. And then we'll go ahead and do the opposite operation, which is to divide by 2, and m is equal to negative 3. It would be a great idea to check your answer by substituting your solutions back into the original absolute value and checking. What we need to remember is we have to have the absolute value symbol by itself, and right now it isn't. There is a 2 that's being multiplied, so we need to get rid of the 2, and we're going to do the opposite operation, which is to divide by 2. So now I have 3d minus 1 is equal to 5. Now I can set up my two equations to solve where I have 3d minus 1 equals 5 and 3d minus 1 is equal to a negative 5. I'm going to add 1 to both sides. So what I have left is 3d is equal to 6. And I'll do the opposite operation is to divide by 3 and d is equal to 2. In this equation I'm going to do the opposite operation, which is to add 1. So I have 3d equals negative 4 and I'm going to divide by 3. Now I can leave this as negative 4/3. I can change it to a mixed number, which would be negative 1 1/3. And in this case I would prefer, if you do want it to be a decimal, that we write it correctly as negative 1.3 repeating. In our next example we have 3 being multiplied times the absolute value as well as 2 being added. So we need to get rid of both of those. We start with the opposite operation to get rid of the 2, and we're going to subtract 2 from both sides. So we have 3 times y minus 6 is equal to 6. Now we're going to divide both sides by 3. Our goal is to get the absolute value symbol by itself, that expression. So we have y minus 6 is equal to 2. And now I can set up my two equations. Y minus 6 equals 2 and y minus 6 is equal to a negative 2. So when I solve, I'm going to do the opposite operation, the inverse. I'm going to add 6 to both sides. So y is equal to 8. And when I add 6 on this equation, I have y is equal to 4. And those are my two solutions for this absolute value equation. So the big question is, can distance be negative? And the answer is no. Distance has to be positive. So if I were talking about the absolute value of x, some number, say being negative 10, then this would be no solution because negative 10 is not a distance. The number 10 could be distance, but the negative adds the direction in, and we only want distance. So our answer must be positive or 0. So absolute value has to be positive or 0. Let's take a look at a couple of these problems. So I said the absolute value is equal to negative 9. This would be no solution because my absolute value needs to be positive. It's talking about distance. Well, what's the difference over here? Well, the difference is that even though it equals negative 9, I have some extra information here, some extra items, values that I need to take care of before my absolute value symbol is by itself. So if I subtract negative 4, I get negative 2 times the absolute value of x is equal to negative 13. And when I divide by negative 2 on both sides, that's going to be a positive answer. So it's going to be the absolute value of x equals 13 over 2. This is going to have two solutions. It's going to either be positive 13 over 2 or negative 13 over 2. Let's go over to this one. If I subtract 6 from both sides to get the absolute value by itself, I have the absolute value of 7x is equal to negative 4. Remember, absolute value must be positive because we're talking about distance, though this one would be no solution. But be careful. This one looks like it's no answer as well, or no solution, but I have the negative 6 that I need to take care of before I can make my judgment. And so I have the absolute value of 7x is equal to 4. This one would have two solutions. Let's look at this one. Looks like it'll be fine, but there is this negative 4 being multiplied times the absolute value. So we need to get rid of that first before we can solve. So now I have the absolute value of x plus 1 is equal to negative 4. Can't happen. No solution. This one looks similar. However, I have negative 16. I have the negative 4 outside the absolute value symbol. And when I get the absolute value symbol by itself, I will be able to solve this problem and get two solutions, because once I divided, then it's equal to positive 4. So let's finish up. Absolute value is distance from 0. Please remember to isolate the absolute value sign and then do the two equations. And remember, absolute value cannot equal a negative number. As you finish, please continue with the reflection.